Okay, I had said that if you go, you know, a million miles east and a million miles north, that you've gone a square root of 2 times a million miles in terms of your change in relative position. And that you can't actually express that, even in a perfect mathematical world where you know you went exactly, or especially in a perfectly mathematical world where you know you went uh, those distances in each direction. And if you went in those distances and you were trying to calculate the square root of 2 by measuring that line, you could never measure it accurately as well. And I was wondering if somebody would point out what Kazuna Makua pointed out, which is that, okay, you do know the position up there. It's, square root of 2 times a million, comma, square root of 2 times a million. That's the position. However, I think we accept this principle, right, that just knowing the name of something isn't enough to say you really understand it. Okay, so we know the name is square root of 2, but the point is it has an infinite number of detail. And so we can never actually know square root of 2. We can characterize what we do know about its relation to other, about its appearance in physical formula, for example, or in geometry. We can name that what we do know and give it that name. But it reminds me of an example Feynman gave. I think it was that his father, he I don't think it was necessarily an apple falling. That's the Newton example. But it was something like, why does that apple fall? And he asked his dad, and his dad's like, well, nobody knows. And then his dad told him, well, we call it gravity. And Feynman points out, this is in the BBC article with Feynman. It's a great article, I mean, a great interview you can find on YouTube. And Feynman pointed out that's where he started to learn as a child that knowing the name of something doesn't really mean you know the why. A lot of people would just answer, well, it falls because of gravity. That's why. But Feynman's father was more careful. He says, well, it's called gravity, but we don't really know why. And it's the same kind of thing with the square root of 2. We can call it the square root of 2, but we don't actually know it fully because it has this infinite number of digits in any notation that we want to express it in. That can be used to go ahead and calculate a position in the real world that has a meaning for us in the real world. To actually calculate the result of this number appearing in an equation means you have to accept an approximation. So that's the point, is that yes, we can still refer to that position as exactly with square root of 2 comma square root of 2, but anytime we actually calculate that out, it's just going to be to some degree of accuracy. And if it's a million miles, not 1 mile, then how many digits we use of accuracy in square root of 2 can make a big difference, millions of miles as well. So that's kind of my point. I think it is a good point, but it turns out to be merely rhetorical because, writing the symbol pi because we don't know the infinite digits is just a way of getting around to the fact that we can't state exactly what pi is.